Okay, so welcome you guys for this special um, lecture recording because I forgot to record in the last class. So I have to record the whole class again for you. Hopefully it will be the same, but at least we will cover the same thing that we have covered in the last class. Yeah. I'm making sure that I'm not missing anything now. So let us just, before we start, let us share some information regarding the block course so that we are having a lab and the block course actually. So let us take a look. Hopefully it is shared. Yeah, I can see on my other device it is being shared. So let us open our time. So timetable, and it looks like it's the old one. I have not updated this one. Let us just open the course outline, because there is slide modification of this one. Let us try to open this one where we have this one to the semester 2, introduction to network and course outline. So we'll be dealing with this one. Okay, so I'll go slow. That's good that I can go slowly. Probably you can select which one you want to go for. Okay, so we have chapter test 1 for face-to-face student on Friday, this Friday. Today is Wednesday, I'm recording this one, and Thursday and Friday. So we have lab 1 and 2 and chapter test 1 for you. So it will be in GG30. We'll start sharp at 10. So you can come 15 minutes early to the class, and probably it will be 45 minutes test, maximum 1 hour. And we'll finish the test first, and then we'll go for the lab 1 and lab 2. And we'll discuss today's lecture is very important for you, because if you don't understand this one, you won't be able to do the pre-test activities. And this is true for the block course also, that will be in 1st and 2nd October. So for Connexi student and online student, you need to come in 1st and 2nd October for chapter test and the block course. So we'll again have the test, and then maybe we'll have 10-15 minutes break. Then we'll start our lab, and we'll try to continue do all 4 labs during these 2 days. Okay. So just to remind that you need to bring your laptop if you have one. Otherwise, you need to take one from Wintech. I prefer that you bring your personal laptop, because some of these settings you need to change that needs administrative right. So probably that will be useful to bring your own laptop. Okay, so this is all about the block course, and I have already opened your block course details, all the information. So this is the marking schedule is given. So we'll start from the lab 1. So there are 4 labs, and all the activities are well arranged, so it should be organized. So there might be some minor mistakes, so that we will go through whenever we are performing, then we can clarify that one. And today's lecture is really important for this lab because most of the thing is based on IPv4 and IPv6, that is learning outcome 4, 6, and 7. So those will be really we have covered, we have started covering from last class. And definitely today's class is not the only class. If we, during the block course or the lab, we will discuss on the, give you brief introduction on the lab, so that will be helpful for you. But if you practice today's lecture, that will be easy for you. Okay, so let us start. So about the chapter test, it will be these two tab. So that means the topic that we have covered is devices and services, this one, and this one OSI and TCP IP model. So you need to go through this file and the tutorial. So there are a few questions on this one. So you have to go through all the quizzes and the practices. And also for the devices, you will find out the sample question. So that is mandatory. You should go through this one for the preparation of the test. Okay, so I think that's all I need to share. Again, I remind you, you need to bring your laptop for the block course. Okay, so let's start with our addressing and naming scheme that we have started in the last class. So this one shows you the IP address, and for any IP address, this is actually represented with the decimal number, and 4-digit decimal is 4-digit decimal number, or it's a 4-digit decimal number separated by the dotted. So it has two parts. One is the network part, another is the host part. So in the last class, I have tried to explain you what is the use of the network part. And today we'll try to give you a bit more sense to this IPv4. And IPv4 is, we will also learn about the necessity of the subnet mask. So today mainly we will spend most of our time with the IPv4 and the subnet mask. And later, if we have some time, probably subnetting, we'll start discussing about the subnetting. So in the first part, we have discussed about network layer, where the IPv4 IP Internet Protocol is being utilized in the network layer and the function of the network layer. And we have discussed about the IPv4, give a brief idea of the IPv4 address. It's of 32-bit long, and we divided this 32-bit in 4 octet, so 8-bit in each of the section. So that means 1 byte in one octet. So there will be 4 8-bit number, 4 8-bit binary number. We are splitting this 32-bit, and then each of these 8-bit we represent with a decimal number. So that is the 4 numbers separated by dotted. Okay, yeah, I think that makes sense. It's 4 numbers. For the 8-bit binary number is converted into decimal number, and that means 4 numbers separated by the dotted. So that is the characteristics of IPv4 that we have learned. And that has 2 parts, 2 section, or 2 portion, or 2 components in the IPv4. One is called the network address, another is the host address. And this is really important to identify the network address whenever message is being transferred from one host to the another host. And if it is if the message has to be transferred from one host, from one network to host in the another network, then you need to identify, that has to be identified with the network address. That means if you can identify the network portion and both the host address network portion have the same address, that means they belongs to the same network. And if this network portion is different between the sender and the receiver, then it will be different address. So based on this, you need to direct your message. If you are sending your message outside a LAN, then that means you need to send it to the gateway router. And if you are sending to within the network, then you don't need to send it to the router. It should be send it through the local switches that we have learned. And this one is looks very interesting. That's why I have added this one in the last yesterday. So this gives you the idea what we are talking about. So this one is your data that has been splitted or that has been divided from your message from any application. Then with this data, so this data has been splitted according to the requirement, according to that makes sense. And then it is added with the port number. So there are few other information is added, but main information is the port address. So that is done in transport layer, just above the network layer. Okay, so from here, so before the network transport layer, all the messages are same. So there is a message itself is a message, and that till in the software level. Okay, so then we are preparing our message data from that message from any application that has to be passed from one network to another network. So that's why we are adding this port number that will allow us to identify this data belongs to which application. Okay, so this is the first address we are adding, that is the port number. So that is identifying the application mesh data from which application. And this is called the segment. So data with the port number is termed as a segment. And with this segment, whenever it's transferred to the network layer, then we are adding this receiver address and the receiver IP address and the sender IP address. So this segment in the transport layer, the communication is actually happening between the application. That means in my computer, I am using a Zoom, and in your computer, you are using Zoom. So data from Zoom application from my computer is transferred to the Zoom application in your computer. So that is happening between end-to-end application. So that's why transport layer communication is termed as end-to-end communication, and that is done with the port number. Now, whenever you are coming to the network layer, in the network layer, then communication is done between host, from one host to the another host, and that is identified by the IP address. So this is in the network layer communication, we call this host to host communication. So that is happening between two end devices. Okay, and so this is between the application in segment in the transport layer, but if you are going to the network layer, it's between the host. And then if you are going to data link layer, is between two devices that are directly connected. It may be in one network, it may be intermediary devices, and that has been done with the MAC address. So this is called the hop to hop, because between directly connected two devices. So you are having in the network layer is between two end devices maybe in same network or in the different network. And so this will be the final destination, will be the end device, the host. But whenever it's transferring, it's moving from one device to another device. So packets are traveling through the network and they are finding out the optimum path. So these packets, each of these packets can independently move and can select any path throughout and whenever it's traveling, it's find the nearest device that it is connected, nearest end device, nearest device that directly connected to each other, and message is jumping from one device to another device where it is connected. And this is done in the process of using the MAC address. So this frame in the data link layer communication established in the frame. So we are talking about the packet that is in the network layer that has the IP address. Now we are talking about that whenever this packet will be traveling, then first thing it has to identify whether the receiver network address and the sender network address are same or not. If they are same, then packet will be delivered in the same network. If the network address are different, then packet will be delivered outside the network device. So that means it has to go through the gateway router. Okay, so that is why we need to know, first thing we need to know is whether your receiver network address and the sender network address are same or not. Okay, so that is what we have started. So in order to do that, though the IP address is actually we represent as a decimal number, but in network devices, they don't understand this decimal number. So that will be processed with some logical operation in using the binary number. So we need to know the decimal number, how this decimal number need to be converted into binary number, or the binary number can be converted into decimal number. So that will be our first thing to learn for today. So we have started with the binary to decimal number conversion, and I will share my other screen first, then probably we can discuss. So I will stop sharing this one, and then let us start sharing the other device so that we can give you. So we have started, if you remember, we have started learning about the binary to decimal conversion. And we have started with, so it's all about the 8-bit number, because our IP address is of 32-bit. So IP address is of 32-bit long. And we are dividing this 32-bit in 4 octet. 4 octet. That means 4 8-bit. Okay, and each of these 8-bit is actually represented with a decimal number. So each of these 8-bit binary number is represented by decimal number. Okay, so binary number, we have only 2-digit binary number. We are using only 2-digit. We are using 2-digit, 0 and 1. So that's why it is called the base 2 number. On the other hand, decimal number, we are using 10 decimal number. We are using 10 numbers. So starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the 10 numbers. So that is why it is called the base 10. Okay. And we have started, as this one is, we are interested only 8-bit number with the IP address. So we'll learn about how we can convert binary 8-bit number into decimal number. So binary. So this one you can find out in the Moodle. Everything is given in details, but we will be talking, we will be sharing this lecture note also. So binary is base 2 number. I can just write base 2 to decimal conversion. So decimal conversion, decimal means is base 10. Okay, so in order to do this, we have learned the position. So we have learned about these 8 different position we can place 1, and for each of these 1 we can identify that I have the position, 8 position, 0, 1, 2, 3, 4, 5, 6, 7. So starting from 0 to 7, this 8 position. If I have 1 in the 7th position, then this number and the rest of the number becomes 0. So if I have this situation that I have only 1 in the 7th position, so this is most significant bit, and this is the least significant bit, LSB. So least significant and most significant. So this one has the highest value. Okay, so if I have this 1 in the highest value, then maximum number will be 128. And we can find out this number by the base and to the power this 7. So that will give me that value. So if I have 1 in the 7th bit or 8 bit rather, so it is 8 bit, I have only 1 and rest of the bit is 0, then it will be 128. Similarly, we can find out that if I have if I have 6th bit of 1, so let us take this one different color. So 6th bit of 1 and rest of them are 0. Then this number can be represented as 64, and that can be found as 2 to the power 6. Similarly, we can continue with this change of the bit, change of position, change of the one position to the right. And so if I change the position of 1 to the right, then this value is becoming half, you can see. So I have, so 1, 2, 3, 4, 5, 6, 7, 8 is too many. So we'll do this one, then divide, 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 okay. So then if I change to here, 5th position, and rest are zeros, then it would be 32 and 2 to the power 5. So I can change this one to 5. Okay, similarly, we'll try to complete the other one, or you can try by making the video, by pause the video, you can try to write down all this, because this is the fundamental to understand how we will convert this decimal value to binary and binary value to decimal. And this does not require much mathematical knowledge. So we can use this one and then this one. Sorry, we will change to different colors. So this one will become 0. This one will become 0. And that means this will become equal to 16. So we'll use this color 16, and this will be 2 to the power 4. So similarly, I will have, sorry. So if I change this one to other position, so I will have 0, 0, 0, 0, and then 1, then 0, 0. Sorry, I have changed the color. So this will become 8, and this will become 2 to the power 3. So let us just finish the other 2, 3. So we'll have 0, 0, 0, 0, 0, 1, 0, 0. So this will give me 4 and 2 to the power 3. Oh, sorry, 2 to the power 2. And then we can have the other two. Sorry, I need to do it quickly. So 0, 0, 0, 0, 0, 0, and then 1, 0. So that will be 2, and that I can write down 2 to the power 1. So similarly, I can write down the last one. Okay, so last one is 1, then rest of the 0. And then this one become 1, and that can be explained to the power 0. Anything to the power is 0 is 0. So this one, how we can find out, if I have most significant bit 1, rest of them 0, then it will be 128. And if we move 1 bit to the right, then it becomes half of that number. So I can represent this one in a tabular form like this one. So I have a table. So this is important to remember. So if you can remember this one, and I am sure that you can remember this one. So it's the 7th position. I will just write down the position first. So 7th position, 6th position, and 5th position, 4th, 3rd, 2nd, 1, and 0th position. So this indicates if I have in 7th position, I have 1, then it will be the number it represent. I will write down the number here. So number it represent will be 128. And then if it is 6th position is 1, then it will be 64, 32, 16, 8, 4, 2, 1. So this is the table. If we can remember this table, then we can easily convert our decimal number to the binary number or binary number to the decimal number. Okay, so this table is very important. So this tells, just to remind you, this tells that I have 8-bit number starting from 0, least significant bit, and 7th is the most significant bit. And this number in the purple color here, this one represents that if I have 7-bit in the binary is 1, then this decimal value of that number with the 7-bit 1 will be 128. If I have only 6-bit 1, that will be 64. And in this way, the number will be changed. Okay. So we have to remember this one, then probably we'll be able to calculate all the conversion. Okay, so we have to just remember from it is starting from 7 and the starting number is 128, then it will be half of that number. Every bit is changing to the right, it will be half. So now we will try to find out binary to decimal conversion. Okay, so let us start with a simple example that I have. So example, I have shown you, just I can share the other device, then I can show you we have given. So this table tells you whatever we have described. Then I have given the steps how to convert from binary to decimal number. So binary to decimal conversion. So I'm using this table and you can see here the first example I have given is, so I have given the steps. So what you have to do, the step 1, evaluate the corresponding decimal value for each ones in the 8-bit number. So you have to identify the decimal value for each of the 1 in the binary number. So let us take an example and then in the step 2, add all these number for the equivalent decimal numbers. So you have to identify the decimal number corresponding to that 1 in the binary, and then you have to add them together. Okay, let us take an example. We'll move back to our other device and try to do this one. So we are minimizing the recording. Okay. So we'll try to share the screen. I think hope is making sense, though I'm missing your voice. So we will start with the example that has been given. Example 1 that is given equal to 8-bit number is given. We will write down the 8-bit number. And then we'll start with, so we'll fill up with the 8-bit number is given 1 1 0 1 1 0 1 0. So this is the first number that is given. So according to the step, first we need to find out the position of ones. So I will mark the position 2 3 4 5 6 7. And then what I need to do, I need to identify corresponding. So let us use the red color. So this one corresponding one in the 7th bit, that will be from this table. I can find out this is actually 128. So in the second one, let's take a different color. So this one circle. So this is 6th bit. So that will be 64. And I don't need to worry about, we'll take a different color. Let's say this is this one. So 0 we'll just ignore. So I don't need to worry about this one. It should be black one. Okay, so this one we'll just ignore. I don't need to consider anything for this one. And then I have, again, let us take this one red color. And this is 1 in the 4th bit. And this 4th one is 16. So I have to write here 16. And then again, I have 1 here. And this one is 3rd bit, 3rd position. So that is 8. So I will write 8 here. And similarly, I can do for this one. And this one is number 1. So number 1 corresponds to this one. So we can make a circle here so that, okay, so we'll use the corresponding color. So this one is red. And then this one is green. And then I have red here. And then I have green. Okay. So this one is 1 that actually corresponds number 2. So we'll write down here number 2. Okay, so I have found all the numbers except this 0. I don't need to care about zeros. Now the decimal number will be, I have to add them together. So 128 plus, or I can use the color, corresponding color for you. So 128 plus 64 plus 16 plus 8 plus 2. So that will be my total number, right? So if I add them together, then we can calculate. Let me bring my calculator. We are getting lazy nowadays. Okay, so 128 plus 64. Hopefully you can see my screen. Okay, so that's all right. So, okay, so we will do the calculation. 64 plus 16 plus 8 plus 2 is 218. Okay, hopefully we have got the same number in the last class. So this is the corresponding number 128, 16, 64, that is corresponding 1, 1. And then this 1/4 is 16, and this is 8, 8. This is 3rd bit 1, that is 8, and then 2. So all zeros we are ignoring, and then we are writing down all the numbers. So this is the decimal number. So we can just, to make it sure that this is a decimal number, we can write as a subscript 10. And the binary number usually we represent. So this is easy. Let us do another example and then we will move to binary to decimal. So we'll take the example from Moodle page. So we'll take the second example. Example 2. And that is given. So we'll write down the similar way, 8-bit. Half. Okay, so we'll write down let us write down the position with the purple. So 0, 1, 2, 3, 4, 5, 6, 7. And we have the number is, we'll use black for this one. So we'll use 1 and then 0, 0, and then 1, 1, 1, 0, 1. So this is my number. So I have to start again for 0, 1, and then 1. I'm just marking alternate 1 with the green color, and then the red color, 1, 1. So these are the ones. And then I can mark this one as 0, 0, and this 0. So there will be no value for this one. And then I can write down the corresponding 7-bit. By this time, we should be able to write down 128. And then third bit is 2 to the power 3. That should be 8. And then this one would be 1. 2 to the power 0 is 1. So we can find out from here also this table. You can write down this table. So 128, 8, and 1. So we have written 8 and 1. Now we will do the red color is 4. 2 to the power 4 is 16. And 2 to the power 2 is 4. Now we have to add them together. So decimal value will be 128 plus 16 plus 8 plus 4 plus 1. So that will give me, we can do the calculation. So it's 128 plus 16 plus 8 plus 4 plus 1. So 57. Okay, so that's easy, right? Okay, so this is how you can convert decimal to binary. So I will move back to our other device. So we can stop sharing and then share this one. Hopefully this has been shared. Okay, so this has been done. So then this is binary to decimal conversion. I have given some examples you can try for your understanding. If you are confident, you don't need to do that. For decimal to binary conversion, so we have done binary to decimal, now decimal to binary conversion. So this is it's not that difficult, but yeah, it's involved 2-3 steps, and this has to be repeated. So I have given this step. So first, step 1, if you are given a number, here I have given 70. So for 70 is a decimal number. Now, if I want to find out the binary number, we will be using the same table as that we have started with, or we have derived. This is 128 to 1, this table. So you have to first find out 70 in this table, or from this table, you have to find out the largest number that is smaller than 70. So you are given a number. So you have to find out in this table what is the maximum number you can find out that is smaller than this one. So you can see here the maximum number 64 that we can find out that is the maximum number, but it is smaller than 70. If you the next number we have is 128, that is higher than 70. So this is sixth corresponding to sixth bit. So what you have to do in step 2, you have to place 1 in this 6th bit. So we have selected one number for the 6-bit binary number. Now from this 70, I have already got 64. That means I have to subtract the 64 from 70. Then I have left with 6. So I need to find out 6, which of the two combination that gives me 6. So now my number is 6. Now I have to forget about 70. I have to start considering this 6. Okay, so with this number, now you have to start repeating the step 1, 2, and 3. So if we go step 1, you have to find out again. Remember, my number now is 6. You have to find out the maximum number, the highest number that is smaller than 6 in this table. So highest number smaller than 6, I can find out 4. Okay, that is in the second position or third position, but 2 to the power 2. So third position, third bit. So I have found 4, and that second position starting from 0 to 2 that I have placed with 1. Okay, so that means I have already got 4 for the remaining 6. So I have left with 2. So that means if in the next step, I have to find out these 2 for these 2. Okay, so you have to go here again. So you have to find out maximum number that is smaller than or equal to. I should use the term equal to. Let us just make this correction because last class also we have discussed about this one. So this should be here. Whenever we are doing this step, should be is smaller or equal. It can be equal but cannot be greater. And this one, the last step, whenever you have found these 2, then we can subtract. So this will, how long we will continue this one? As long as this the difference does not become equal to 0. So previous step I had 2, now I have found these 2. So that means I have to subtract these 2, that will become equal to 0. So now I have the first position is 1. So I have to place this 1 and this becomes 0. So I have to stop. So in this process, what I have found all the ones of the 7-bit corresponding to 70. The position of ones we have identified. So I have the 6th bit will be 1 and second bit will be 1 and the first bit will be 1. So that will make us 70. Then the remaining bits, I have to save it. So remaining bit, I have to make equal to 0. So that's what we have done. So fundamentally, it is of 3-step process. So first, you have to identify, start with the actual number, find out the highest number smaller than this number from the table, and set that corresponding bit to 1, and subtract, find out the remaining number, and start repeating this 1, 2, and 3 as long as it does not, the difference does not become equal to 0. So we have here 0, and then I will stop. And I have find all the ones, and the remaining bits will be 0. So that will be the corresponding number of 70. Okay. So we'll do some exercise that might clear the idea. Okay. So the exercise given here is, example given here is 35. So figure below shows the conversion of 35 into decimal number. So let us try with this one. We want to start with 35. Maybe we can do another one. So let us stop sharing this one, go back to my other device. What we will do? Probably and find out this one. Okay, so we are trying to do conversion from decimal now, decimal to binary. Okay, we are trying to convert 35 of 10. Now what we need to do, we need to use that table again. So we'll write down this table. So this table is useful. I find this easier way of conversion, at least for 8-bit. So we'll write the position 0, 1, 2, 3, 4, 5, 6, 7. And we'll write down the numbers corresponding to that bit. We'll use the purple again. So 128, 64, 32, 16, 4, right? 8, 4, 2, 1. Okay, so my given number is 35. So in this table, I have 64 is higher, 32 is smaller. So I can identify, the first number I can identify is 32, which is smaller. I can just write down 32 is smaller than 35. Okay, and that means, but this is, we have so many smaller, this is the largest smaller number, or largest or highest smaller number than the given number. So that means the first bit already we have identified, this will be 1 in my binary number. Okay, so then I will subtract this one, 35 minus 32, that will be 3. So next step is 3 is my number. So 3, I need to find out in this table, highest number smaller than 3 that I can identify is 2. So that means this bit will become equal to 1. And then if I subtract 3 minus 2, that will be equal to 1. And now I need to find out for 1, which is the highest number. So that will be definitely equal to 1. So that will be equal to 1. So 1 minus 1 would be equal to 0. So that has become 0. So I have finished all ones. So what I have to do, next one is I need to place 0 for my rest position. So first I will remove this one, and then the rest position I will place 0, 0, 0, 0, and this is 35 of decimal number. So my number will become equal to, so what is the 8-bit number corresponding to this one? 0, 0, 1, 0, 1, 1. So that is my binary number, that is equivalent to 35, 10. All right. So I think this is clear. So we'll do one more problem from our example. So let us do one more with the highest number. Say we will start with example 2. So the number we are talking about 223. Okay, this is my 10. So we will do again. You can write down your table. And write down the number with purple colors. So 128, 64, 32, 16, 8, 4, 2, 1. And then we can write down here the position. This will be 0, 1, 2, 3, 4, 5, 6, 7. So this number is 223. So I have to find out the maximum number smaller than. So in this table, maximum number can have is 128, right? So we'll use this bit. So we'll use this bit as 1. And we'll subtract this from this 223. We'll subtract 128. So if I do this calculation, 223 minus 128, that will give me 95. So next number I have to look for, I have to now forget about this one. So we have already done this one. So we'll forget about this one. So we'll start with this 95. So this is my 95. Now in this table, I need to find out the number, highest number that is smaller than 95. And that you can easily recognize the highest number smaller than 95 is 64. So that means I can place 1 here also. Then I need to subtract 95 minus 64. That I set 1. So that will give me around 131, right? So 1 and 3, yeah. So that is 31. Now next step, I need to find out this number is 31. And now I need to forget about this one. So with this 31 from the rest one, highest number, smaller than 31 will be definitely my 16. So that means this one now will become equal to 1. Okay. So now we have found our next number. So 31 minus 16, that will be 15. So we have to forget about this one now. We start about 15. So if you take a look of 15, then definitely the next number smaller than 15 is 8. So that means I will have 1 here. So that means I have to subtract from 15 minus 8, that is equal to 7. So my next number is 7, and I need to find out smaller than 7. Smaller than 7 is 4. And that means I need to set this one equal to 1. And then I have got 4 that I have to subtract this 4. 7 minus 4, that will be equal to 3, right? So now my number is 3 again. So you have to forget about this one, number is 3. So highest number smaller than 3 is 2. So this is my 2. That means I need to set 1 here in this position and subtract this 3 minus 2 is equal to 1. So we are continuing because we have not got the difference 0. So then my number is 1. So now we need to find out 1. So this is equal. So we can consider this one, and then this is becomes equal to 1. So this will become equal to 1 minus 1. That would be equal to 0. So we have got 0. That stop. So we'll stop our conversion. So now the remaining bit, we can find out which of the bit is 0. So this is the bit where I have 0. Now your number becomes, binary number becomes 1, 1, 0, 1, 1, 1, 1, 1. So that should be 8-bit. So 4-bit and 4-bit. So 8-bit. So this is the binary number of base 2. That would be equals to 223, 10. Okay. Hopefully that has clarified the conversion. So you can try from the Moodle page. There are a few examples are given. So you can try those examples. So this is the examples here. So these are the tasks. So you can try with this one. So that should give you a good idea. Okay, so the conversion we have learned about how we can convert. Now we are learning all these things to have understand how we can distinguish, how we can differentiate the network portion and the host portion from the IP address. So whenever we are talking about the IP address is represented 4 numbers. It's not 4-digit actually. It should be 4 decimal numbers with slashed prefix, right? So I can represent, this is decimal number 1, D1, D2, D3, D4. These are the 4 numbers separated by the dot. And each of these decimal number D1, D2, D3, D4 is corresponding to 8-bit binary number. And then we are writing with a /x. So that means /10 or 5, whatever it is. So this /x, what does it mean? Is this tells that how many bits of these combined binary number is used for the network address. So this X actually represents from the left how many bits. So number of the most significant X bit. So starting from the left, you have to count X bit of 32-bit number that corresponds the network part of the IP address. So with this representation with /x or slashed prefix, we actually can represent, actually give the information how many bits of these IP address or equivalent binary IP address is used for the network part. Okay, so if I know the network part, then I can find out the host part, because altogether is 32-bit. If I know that 10 bits is for network part, then remaining 22 bits will be host part. Okay, so we can find out 32 minus X, that will be giving the host part. Okay, so the given example is here, that I have an example that 192.68.40.12/24. So this indicates that I have 24 most significant bit will be used for the network address, and 12-bit remaining 8-bit, remaining 8-bit 32 minus 24, that 8-bit will be used for the host. Okay, so network part we are using with the /24. Okay, so this is the information we can, as a human, we can identify with the / prefix, but that cannot be identified by the network device, because network device has to process sending the message, or packet has to be sent based on the IP address. So network has to be able to identify this network address. So this slash prefix is well represented for us to understand, but network device, host, or the router, they will not be able to understand this one. So what we can do, the network device performs, instead of doing this one, network device actually performs some logical operation to distinguish network part and the host part. And this logical operation is actually the AND operation. It performs the AND operation. Now, before we move to that one, how it is done, we can understand. I think you might have already know this truth table of this two input AND gate. So we can represent the input in this way. So 0, 0, both 0 will give you 0. 0, 1 will give you 0. 1, 0 will give you 0. So 1, 1 will give you 0. So AND operation means any of the input is 0, that will become equal to 0. Now that we want to understand that if I combine left A bit, so input A, both the, if I keep all the time, if I set this input A to 1, then we can find out interesting relation that the output is actually all the time varies depending on B. If 0 is B input is set to 0, then output becomes 0. And if B input is set to 1, then it will be 1. So that means if I have two input AND gate, and if I keep one of the input 1, then the output is actually depends on the other input. If I have 0 in the other input, that represents 0. So in the network section, in the IP address, if I want to find out the network part, I need to retrieve this network section without any modification, right? So if I want to do that, I can easily find out, if I take another number with this network bit, all the bit equal to 1, and do the AND operation, then I can, with this AND operation, I can retrieve only this part. That means the host part I need to set to 0. So I can set the network part with all ones. That will give me the output will be then dependent on the IP address. And if I set host part to 0, then whatever the host value, that will give me 0. Because if I have both 0, then it does not depend on the input, right? It makes all equal to 0. So that is actually the fundamental of identifying the network part. The network device can identify. So as I have mentioned, that in order to identify, I need to set this network part to 1. So that is done by called subnet masking. So we prepare the IP corresponding mask address by setting the network part with all ones and the host part to all zeros. So here I have the IP address configuration of 24-bit. Most significant bit will be my network address. So these 24-bit, I have put all ones. And the host part I set to 0. And this is called the subnet mask. So subnet mask is very important. This is actually used by the network devices to identify the network part of the address. Okay, I think that makes sense now. So with these two configuration, I can find out what is the network address. Now, subnet mask usually represented based on the binary number. You can represent what would be the subnet mask. With the 24-bit, all ones, that will be 255. So I can write down 255, 255, 255, 0. So this indicates, so this is another way of representing the network address that actually tells that I have used all 24 bits, most significant bit for the network, and the last 8 bit is for the host. Okay, I think that makes sense. If you have any question, then you can send an email or message so that we can discuss. Okay, so we can try to do one problem with this one to identify the subnet mask. Probably we have some address. So before we go to that point, we can also find out the host, how many hosts I can connect in a network. So you can see that if I have been given this IP address, that means 24 bits have been allocated for your network, and you are having only 8 bit for the host. Now, how many hosts I can connect? We can easily find out using the possible combination, binary combination I can use. So let me just stop this sharing, and then we will go back to the other device and share the screen. Okay, so we will go back here. So let's talk about that example is given. So I can represent, so whenever I am writing an IP address, I can write in two ways. One is called 192.68.40 and .12/24, right? So this is one way of writing the IP address, or I can write down with subnet mask. So I can write down 192.68.40.12, and then this is the IP with /prefix or I can write down IP address and subnet mask. So that completes our information about the IP address. So I can write down the same 24 bits. I can write down as 255, 255, 255. So all bits are 1. That makes 255. All 8 bits are 1. And then the last 8 bit is 0. Okay, so from here, I want to find out how many hosts I can connect, number of hosts, number of allowed host ID. And also we can find out the range of the host ID. So first I need to find out what is the number of host bit, number of host ID bits. So that I can find out total length is 32 bit. I have allocated 24 bit for network. So rest 8 bit will be for the host. right? Now, can we use all these combination? Now let us take an example. What are the different combination? How can I find out with 8-bit number what is the total combination? So let's take 2-bit number, 2-bit binary number, and how many combination we can find out for this 2-bit. So 2-bit starts with 00, and then I can have another combination 01, another combination 10, and another combination 11. So these are the 4 combination. And how can I find out? This can be calculated by the base to the power number of bit. So we have base 2 and number of bits of 2. So that will give me 4. So I have 4 combination. If I have 3-bit, 3-bit binary, 3 bits binary, then we can find out 2 to the power, 2 is the base and 3 bits. So that will give me 8 combination. And if I write down, this will be like this one, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Okay, so these are the combination. Now, can we use all these combination for the IP address? The first thing you need to think about the subnet mask. Whenever we have talked about the subnet mask, I have the host part. This is the host part, that is 0. That means if I convert this one, this subnet mask, then I will have all ones, 1, 2, 3, 4, 1, 2, 3, 4. So this is 8-bit. Then 1, 2, 3, 4, 1, 2, 3, 4. This is 8-bit. Then I will have 1, 2, 3, 4, 1, 2, 3, 4. So these are 8-bit. So these are the 24-bit, and the rest of the 0-bit, rest of the bits are 0 for the subnet mask. Now you can easily think that if I use a host with this IP address having all zeros, they will conflict with the subnet mask for the that is being used for identifying the network part, right? So this cannot be used with all 0 in the host. So we cannot use all zeros for the host bit or in the host bit. All zeros in, did I share my screen? Okay, so all zeros in host bits cannot be allowed. Why? Because that is allocated for subnet mask. Okay. The other one is the broadcast address. So for a LAN, we need to have a broadcast address. So let me write down in different color. So we need another one for the broadcast address. We'll go for this one later. So broadcast address. And for a local area network, there is a standard of having the broadcast. So we are not using actually all the IP address. You might have 100 1000 devices. So when you broadcast, you cannot allow all the IP addresses in the sender address, because in the packet you have a specific field for 8-bit IP address. So in that case, this one, the all ones in host IP bit, host ID bits is allocated for broadcast address. So that means if I want to send the message to all the devices, we are using all ones in the host bits or host ID bits. So that cannot be also used. So we cannot use individual IP, cannot be used for individual IP or individual host IP. I cannot use this individual host IP with all ones. So you cannot use 255, sorry. So I cannot use 255.255.250, sorry, this will not be the address. Address will be 192. So what is the address we have started with is 192.68.40. This is easy, 192.68.40 and then 255. I cannot use. And also I cannot use 192.68.40. So these two cannot be used. So that means remaining bits, remaining numbers we can use. What are the remaining numbers? We can find out. So allowed IP address, allowed number of host ID. First, I need to find out what is the total combination. 2 is the base, number of host bit, and then these two I have to subtract. So if I subtract these two, then this will be give me total number. Now what would be the range? Range will be, we need to start, say for this particular example, I cannot use 0. So next one will be the first ID. So 192.68.40.1 is my first ID. And then it will continue 1, 2, 3, 4. And I cannot use 255, but I can use 192.68.40.254. So this is my last ID. Okay, so these are the ranges. So we can find out what is the, for this particular example, the number of host bit is 2 to the power 8 minus 2. So that will give you 6, 5, 5, I think is, I need to do calculation. 2 to the power 8 minus 2. 2 to the power 8 minus, okay, so this is not that much, this is another. So 2 to the power 8 is 254. So 254, right? So this is the total number of host ID I can use with the 8-bit of host address or host bit. Okay, so for this one, we can easily identify because of the network part, because it's complete 3 octet have been used, but sometimes you might be finding out the fraction of the host, fraction of the one of the octet can be utilized for host, for network. So let us do this example. We need to find out, say I want to use 172 134 68 and 32. So this is my IP address, and I want, instead of having complete 3 octet, I will have 2 octet plus 4. So 16 plus 20 is the network address. So first thing we need, if I given the prefix, I need to find out subnet mask. Subnet mask. So first thing, we need to convert this number into decimal number. So 172, we can start with 128. So 172 minus 128. So that will give me 44. So I will have 1 bit will be 0. Then I can write down this is 128, 64, 32, and 16, 8, 4, 2, 1. So 128 is 1. Then I have 44. Then I have to put 1 here, subtract 32. Then I have 12. So I can take 8 and then 4. So this is my 172. So the rest of the number will be 0, 0, 0, 0. So this is my first, this is corresponds to 172. Then I need to convert 134, that will be 128 minus 6. So minus 6 will be 4, 2, and rest will be 0. So that will be 134. And then I can find out 68. 68, I can find out 64 and 4, and the rest will be 0. 68. And then 32. 32 will be only 1. Then rest will be equal to 0. Okay, so I have, this is my, so this is not the subnet mask. This is my IP address, IP. And these are the 4 octets, IP version 4, 4 octet. So I can just write down this one. Let us write down this 4 octet in one number. So we will make a big box and then divide this one and then divide. Probably we need to do a couple more. I think this is 16. So then we need to do a bit more thing. I'm not sure whether we are making too many, but let us try. Okay. Then we'll start from this one, from the rightmost bit is 1, 0, 1, 0, 1, 1, 0, 0. This is my first. Then I will have 1, 0, 0 0 0 1 1 0, and then I can have red 0. Red does not look good, so let us try with a different color. What would be good? This one. Okay, so this one would be 0 1 0 0 0 1 double 0, and then the last one. Last one we can take this one. Good. So we can take 0. It's not change. So 0 and 0, and then 1, then 0 0 0 0 0, right? So this is my IP. Now I need to make the subnet mask of 20 bit. So that means subnet mask will be, so similarly I will make a box and 2 4 8 then 16 32. So I have to make each of them half. That will make 32. And then I have to mark from here up to 20. So 0. Wow. I don't want to confuse. So it is 20. So the host bit, number of host bit is equal to 32 minus 20. That will be 12. So I can mark 0, 1, 2, 3. Let us take different colors. So we'll take blue. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is my 12-bit, right? And this will be 12. And the rest will be my network part. So from here to 31. So this will be the network part. And in order to make a subnet ID, subnet mask, we have to plus 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. So how far we have to make up to this part? And this is my host ID. So host part. So that will be equal to 0. So I will set 0 0 0 0 0 0 0 0 0 0 0 0. So this is my subnet mask. Okay, now from here, I have already identified my subnet mask. Now, if I want to represent this subnet mask into decimal, then I have to group them into, let me select one, purple. So into 8-bit. So 1, 2, 3, 4, 5, 6, 7, 8. So this will be grouped together and all of the bits are 1. So that will give me 255. And then I will group 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So up to this one. So this is again 8-bit. So that will be 255. That's fine. Now, then the next 8-bit is not completely 1. This 4 and this 4 will be grouped together. So then I need to find out what is the value. So it is 128 plus 64 plus 32 plus 16, right? So we can do the calculation. So 128 plus 64 plus 32 plus 16. So that will give me 240. So that means this one is no longer 255. This is 240. And then this one is 0. So last 8-bit is 0. So I can, so subnet mask in decimal format will be subnet mask in decimal. So in decimal will be this one. And this is in binary. Okay. So we can find out from here, we can find out the network part. So I can just write down the network part. I'm not sure it will be, I can do it here. I'll just do it here. So let us, we can just remove this one. And then we can just write down here with a different color. So network address. So we want to find out the network address. So this one here is the network address. How to find out the network address? So we'll divide this one again with 32-bit, 2, 4, 8, then 16, and 32. So we have to divide each. Okay, so these are the 32. Then what we have to do? We have to do the AND operation. So from here, let us take a different color. So this one, so bit by bit AND operation. So it would be good. We can take this one. Okay, so what we have to do? It looks same. So red, yellow, I think this one will be good. So we have to combine these two. So bit by bit, I have to do the AND operation. So first one, 1, 1, it will give 1. And then the next one is 0, 1, that will give 0. And then the next one will be 1, 1, that will be 1. And then this one will be 1, 0. So in this way, I can, if I do the operation, then it will be 1, 1, 0, 0, 1, 0, 0, 0, 0, 1, 1, 0. Up to this part is fine. Then I will have this part only 0, 1, 0, 0, right? So these are the 4-bit. And then, so this 4-bit will be corresponding. So up to this one is corresponding. So it would be 0, 0, 0, 1, 0, 0, another 0, right? So 0, 0, 0, 1. So up to this one is, so how many bits? 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this one, the last one is extra. Okay, so we'll have this one. So this is my network address. So we can find out the first bit, first 8-bit is same as my IP address. So that I have IP address 172. So I can write down 172. And the next 8-bit is also the same. So next 8-bit is also same. That will be 132. So I don't have any change. but the last one is 4-bit. I will have the same number, but the rest bit will be different. So in the next one, I have actually, this is my 8-bit, but I will have only 4-bit in my network part. So this means this one will be my network part, and this one will become 0 because this corresponds to 0, right? So this one will not have, so that means it will not be 68, it will be only 64. So this will be 64, and then the next one will be 0. So this is my network address. So you see, the network address is not always 3-bit. It depends on how many bits you are allocating. Based on that, you can find out the network address is slightly different than your IP address. Okay, now the next part I need to find out is what would be, how many network ID we can use, or host ID I can use. So that would be number of allowed host ID would be equal to 2 to the power 12 minus 2. So 12 is coming from network part, 32 minus 20, that will be 12. So this one we can find out the calculation. So 2 to the power 12 minus 2. So that will give me 4094. Okay. Now first ID, what would be the first ID? So first ID would be equal to first ID. So I can take a look of my network address. So network address is 172.132, then 64, and then the last bit we can make it 1. So that means 64 0. I don't need to write 0. So I can write down this one to 1. Okay, so this is my first ID. But here the last ID, definitely the last bit will be 254. That will be the last ID. And 172 will be the same, and 132 will be the same. There will be no change. But if you take a look of my network address with this one, so this one is my network address. So host ID will not be able to change. And you can see these are the 8-bit, 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8-bit group together. And then 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8-bit group together. And these are the 4-bit I have that will not be changed for the next 8-bit. So next 8-bit, 1, 2, 3, 4, that is involved in this octet. But this 4-bit, I cannot change anything. So this one will remain as it is. And the maximum I can have is all of them 1. So this 4-bit becomes 1. Clear? So I think it's clear. So I cannot change this 4-bit because this is network part. This section is network. So network part, and this section is host part. So this host part I can change for the increasing each of the bit. I can change it to maximum to 111, but this one will remain same. So in third octet, I can have maximum 0, 1, 0, 0, and then 1, 1, 1, 1. So this will give me 1, then 2, then 4, then 8, then this one will not be having any, 16 will not be there, 32, so this is 64. So 64 plus 8, 72, 72 plus 4, 76, 78, 79. So this one can be of maximum 79. So this is very crucial. So this is not going to 255 anymore because only 4-bit I can change. That can give you the maximum of 79. But the last bit can be of 255. Okay. Now, what about the broadcast address? So once you have find out last ID, then you can find out the broadcast address. So what broadcast address will be 172.132. So these will be all ones with the host ID that will give me 79, and the last bit will be 255. Okay, so this is my broadcast ID. Okay, I think this is what we have covered in the last class. I will try to share this homework also, this class exercise. And this will be required for your test also. One more thing left is the subnetting. Probably we can discuss in my future recording. Okay, so hopefully I have done recorded well. And if you have any question, just flick me an email. Thank you.